Welcome back to the Deep Dive, your shortcut to being well-informed where we slice through the data.
Great to be diving in again.
Today, we're focusing on a market that's, well, it's absolutely vital to our digital world, but maybe doesn't get the spotlight often.
The electronic components marking machine market.
Exactly. And our mission here is really to unpack its growth. We're looking at global insights, tracking things from 2021 right through to 2033.
And the source material is quite detailed. We're talking revenue figures, growth rates, region by region, country by country.
Yeah, it promises a really data-rich picture of this specialized, but as you said, globally significant segment.
Absolutely. These aren't just simple labels.
No, definitely not. We should clarify that. These are sophisticated machines. Think lasers, inkjet, maybe even chemical etching.
Making permanent marks on tiny electronic components, microchips, circuit boards, resistors, you name it.
Right. And that mark is critical, isn't it, for traceability, quality control?
Verification, supply chain security, fighting counterfeits. It's fundamental in today's electronics landscape.
Okay, so let's start big picture, the overall global market view. The numbers show pretty consistent, solid growth. We're seeing sales revenue jump from roughly $3.4 billion in 2021.
So 3,397.66 million to be precise.
Right. Climbing to over $4.3 billion by 2025, and then projected way up to $7.2 billion by 2033.
7,205.46 million. That's quite a trajectory.
It is. And that works out to a compound annual growth rate, a CAGR, of 6.465%. For what some might see as a niche area, that feels significant. What's that global momentum telling you?
Well, what's fascinating here is that steady growth, it really underscores this underlying shift. It's not just about making more electronics.
Right.
It's about the growing demand globally for
Right.
total traceability and quality assurance. Every single component in your phone and medical gear in critical systems.
Needs to be verifiable.
Exactly. So this expansion, it signals a foundational need for these machines right across the electronic supply chain. It's driven by regulations, sure, but also just basic consumer and industry expectations now.
That global number is strong, definitely. But as often happens, it probably hides a lot of variation when you look closer, right? Region by region.
Absolutely. That's where it gets really interesting. The regional insights paint a much clearer picture. They reveal these unique local dynamics, different drivers. It's definitely not a uniform story everywhere.
Okay, let's dig into that then. Starting with North America, the figures show revenue was $967 million back in 2021.
Just under $1 billion, yeah.
And it's projected to grow to nearly $2 billion by 2033. That's $1,950.66 million with a TGR of about 5.9%.
So solid growth.
Solid, yes. And digging in, the U.S. is predictably the biggest chunk, projected at over $1.45 billion by 2033, growing at 5.677%.
Okay.
But here's what caught my eye. Canada. It's expanding faster, 6.87% CAGR. And Mexico is strong, too, 6.3% CAGR, hitting over $250 million.
Right. So different speeds within the region.
Yeah. What's driving that in what we generally think of as a pretty mature market?
Yeah. Well, North America's strength reflects its advanced electronics sector. The U.S. is huge, but it's mature, like you said. The faster growth in Canada and Mexico, that could link to specific industry niches. Canada, for example, has a strong aerospace and defense sector. Think extreme precision marking needed there.
Ah, okay. High-stakes components.
Exactly. And Mexico's a major hub for automotive electronics, contract manufacturing, places where efficiency and, supply chain visibility are absolutely key.
So maybe they're adopting newer tech faster lasers, things like that.
Could be. Integrating advanced marking tech to meet those specific industry demands might explain that faster growth rate.
Interesting. Okay, let's hop across the Atlantic.
Yeah.
Europe, the market there grew from about $684 million in 2021.
Projected to hit $1.37 billion by 2033.
Right, with a CGR pretty similar to North America, actually, 5.865%.
Okay.
But the mix within Europe is really fascinating. You've got France surging ahead, 7.355% CAGR.
Wow, that's significantly higher than the average.
Yeah. Compare that to the UK, just under 5%, or the Nordic countries, like Sweden, down around 3.4%. What explains those kinds of differences across Europe?
That diversity in Europe is very telling, I think. France's surge. Well, it could be tied to its strengths in, say, high-value manufacturing, luxury goods with electronics, maybe aerospace again. medical devices.
Things needing really precise marking for compliance or brand protection.
Exactly. And then you mentioned the rest Europe category was also growing fast.
Yeah, over 7% CAGR there too.
That likely covers countries maybe building up their manufacturing capabilities, whereas the UK, the Nordics, maybe more established markets, the foundation's there, so growth is more about incremental upgrades, specialized production.
So different stages of industrial development or investment playing out.
Precisely. Different speeds of adopting new manufacturing tech, maybe different regulatory pressures kicking in.
Makes sense. Okay, let's pivot now to Asia Pacific, APAC. This seems to be the real engine room for growth here.
Definitely stands out in the numbers.
It climbed from $1.3 billion in 2021, projected to reach nearly $3 billion by 2033.
So $2.94 billion roughly.
And the highest regional KGR by a decent margin, 7.087%.
That's strong.
Very strong. And within APAC, some real standouts. India showing the fastest growth in the region, an incredible 8.266% CAGR.
Wow.
And Singapore and Southeast Asia are also posting really strong growth, over 8% there too. China and Japan are huge contributors in absolute terms, of course.
Naturally, given their manufacturing scale.
So APAC's central role in global electronics, it makes this growth seem logical, but what are the specific factors really pushing demand for marking machines there?
Well, it's not just scale, though obviously that's a huge part of it.
Right.
Think about first the sheer volume. Consumer electronics, smartphones, laptops, all the IoT gadgets they need, incredibly fast, efficient marking. High speed is key.
Okay, volume and speed.
Second, anti-counterfeiting. That's a massive driver, especially in places like China, India. You need rock-solid traceability.
Secure.
And third, just the complexity of modern global supply chains. You need to mark components accurately, instantly for logistics, for identification. It's non-negotiable. So it's volume, security, and supply chain needs all coming together.
Got it. Okay, moving south now, South America, also showing some pretty impressive expansion. Revenue grew from around $233 million in 2021, heading towards $544 million by 2033. That's a CAGR of 7.534%, quite high.
Higher than the global average, yeah.
And what's really interesting here, Argentina and Colombia, both hitting over 8% CAGR. That seems like really punching above their weight on the global stage.
It certainly does. That strong growth in, emerging players like Argentina and Colombia within the continent, it really highlights increasing industrialization.
Driven by local demand.
Likely a growing middle class, more domestic demand for electronics, maybe automotive parts, appliances. So you see more investment in local assembly, local manufacturing.
And they need the basic tools to do that properly.
Exactly. They're rapidly adopting foundational technologies like these marking machines to build out robust supply chains, ensure quality control as their own production ramps up.
Okay. And finally, let's quickly touch on the Middle East and Africa, both showing steady expansion, perhaps not as dramatic as APAC or South America, but consistent.
Steady growth is still growth.
Right. The Middle East grew from about $118 million in 2021, projected to hit $213 million by 2033. That's a 4.87% CAGR. And Africa expanding from $82 million to $183 million over the same period, a CAGR of 6.465%, interestingly, right on the global average.
That is interesting.
So what connects the dots across these diverse regions, Middle East and Africa?
I think the common thread is economic diversification and infrastructure investment. In the Middle East, you see countries like the UAE, Saudi Arabia investing heavily in moving beyond oil into high-tech manufacturing. In Africa, there's rising demand for localized production, consumer electronics, telecom gear, maybe industrial equipment too.
So as they build up those manufacturing bases,
the need for component traceability, for quality control, just becomes essential. It drives that consistent demand for marking solutions as their ecosystems develop.
Okay. So we've toured the world, looked at all these figures, these regional stories. Let's try and synthesize this. What does this all mean for you, the listener? How do we tie all these threads together?
Well, if we connect it back to that bigger picture, global supply chains, consumer expectations for quality, it's clear these marking machines are just fundamental.
Integral, really.
Absolutely. Integral for traceability, for compliance, for quality assurance in pretty much all electronic manufacturing now. And they're in steady demand everywhere. Mature markets, emerging markets.
Even though the growth rates differ a lot.
Right. They vary significantly by region, even by country. But every single region we looked at shows positive momentum. No one's going backwards here.
And the drivers seem consistent.
Largely, yes. It's that mix. Stricter regulations demanding better tracking, ongoing tech upgrades in manufacturing itself, better lasers, faster inkjets, and just the sheer scale-up of production worldwide to meet this, frankly, insatiable demand for electronics.
It's like an indispensable layer of precision built into everything.
Exactly. Every piece of tech you touch.
And that brings us to the end of this deep dive on the electronic components marking machine market. I really hope this detailed breakdown has helped you grasp the global opportunities, the regional differences, and just the huge market potential for these marking technologies.
Yeah, and maybe as you go about your day, just consider this. That quiet but relentless growth we talked about in these marking machines, it really speaks to a fundamental shift happening underneath everything in the global economy.
How so?
Well, it's not just market size. It's about the increasing value we're placing on precision, on accountability, on reliability in every single electronic device we use.
From phones to medical implants?
Right. The ability to trace and verify every component, it's becoming absolutely non-negotiable. So maybe ask yourself, what does this quiet, steady growth in something so specific tell us about the future of manufacturing? And maybe even about consumer trust?
That is a great thought to end on, something to really mull over. Thank you for joining us on this deep dive.
My pleasure.
And we invite you to continue exploring these kinds of insights with us next time.
Welcome, curious minds. You've tuned into The Deep Dive, your shortcut to being genuinely well-informed on, well, topics you didn't even know you needed to know about. Today, we're diving into a market that might sound a bit niche at first glance, but it's actually foundational to our modern world. Electronic components, marking machines. Yeah, these are the kind of silent workhorses putting those tiny, absolutely crucial labels on everything. From the smallest microchips in your phone to, the complex circuit boards in an electric car. Our mission today, to pull out the most important bits from our source, electronic components marking machine market dynamics. We want to really understand why this seemingly quiet industry is, in fact, so critical, so vital in today's high-tech manufacturing. We want to give you those sort of aha moments about something you interact with daily but probably never really think about.
And you've hit on something really vital there. What's truly fascinating, I think, is how these machines have fundamentally shifted their role. They used to be seen as, well, just a supportive process, almost an afterthought on the production line. But now, especially in advanced manufacturing, they've really evolved. They're a mission-critical component. It really highlights the incredible precision and, the interconnectedness that modern supply chains demand, and how these machines are just key to both function and transparency.
Okay, so let's unpack this a bit. When we look at the core drivers, what's really fueling the growth in this market? What's standing out?
Well, a huge driver, definitely, and one with really far-reaching implications, is the increasing demand for product traceability and identification. I mean, think about it. Global supply chains are just incredibly intricate now, right? Components coming from all over the world. So accurate tracking isn't just like a nice to have anymore. It's an absolute necessity. These marking machines, they imprint vital data, serial numbers, barcodes, batch codes right onto these tiny darts.
Right, so it's not just about knowing where something is right now, but its whole history,
Yeah.
like a digital passport for every single component.
Exactly. That's a great way to put it. It's about ensuring compliance with really strict international quality and safety standards. And crucially, it's a frontline defense in anti-counterfeiting strategies. Huge issue that. We're talking about regulatory and operational requirements that honestly wouldn't be possible without this kind of precise permanent marking. And actually, what's truly groundbreaking here is how this level of traceability is kind of reshaping the warranty landscape.
Yeah.
It pushes manufacturers towards, well, unprecedented levels of accountability. If there's a defect, you can trace it right back to the batch, the machine, even the specific moment it was produced.
Wow, that's quite a connection. Accountability tied directly to a tiny barcode.
Mm.
Okay, now here's where it gets really interesting for, well, anyone who loves their gadgets.
Yeah.
Because another huge driver is obviously the sheer growth of the electronics and semiconductor sectors. I mean, we're all carrying around so much smart tech.
Oh, absolutely. We are seeing an explosion across the board. Consumer electronics, yeah, but also advanced automotive tech and the massive expansion of IoT devices, the Internet of Things. And it's not just more devices, it's that manufacturers are producing components that are more compact, more densely packed than ever before. This miniaturization challenge, it means marking machines have to deliver incredibly high precision and speed.
Yeah, I can imagine. You're talking about printing legible data onto something smaller than a grain of rice maybe,
Hmm.
and doing it at speeds that would make a normal printer blush
Yeah.
without actually touching the delicate surface.
Precisely. That's exactly it. And that's where non-contact methods like lasers become absolutely essential. And just the sheer volume coming from major production hubs, think Asia Pacific, North America,
Hmm.
that drives demand for highly scalable, non-contact, high-speed marking technology, stuff that can keep up with assembly lines churning out millions of units a day.
Okay, and linking that to the sort of broader manufacturing revolution that's happening everywhere, this transition towards automation, Industry 4.0,
Hmm.
that must be a massive factor too. Just for our listeners, Industry 4.0 is basically about creating these smart connected factories, right? Ones that can make decisions in real time.
Absolutely, spot on. More and more organizations are upgrading to fully automated, intelligent production lines. It's the way forward. And these electronic components marking machines, especially the advanced laser and inkjet ones, they're designed specifically to integrate seamlessly into these workflows. They're not just adding a mark anymore. They're equipped with sensors, software. They can reduce human error, improve consistency, offer real-time quality control data back to the main system. They've genuinely transformed from just tools into, well, intelligent components within a whole connected factory ecosystem.
Hmm. But, like with any booming industry, there are always challenges, aren't there? What's maybe standing in the way of even faster adoption, or perhaps limiting who can actually jump into this advanced marking tech?
You're right. Yeah, there are some significant hurdles. The first one that springs to mind is the high initial investment and maintenance costs. While laser-based systems offer really superior performance, that performance often comes with a, let's say, steep price tag up front. And it's not just buying the machine either. Businesses also have to budget for ongoing upkeep, calibration, specialized technical support. It adds up.
So for a smaller manufacturer, maybe a medium-sized one, that's not just a barrier to getting started, but potentially a barrier to upgrading their existing systems too.
Exactly. For many SMEs, these expenses can be genuinely prohibitive. It might force them to settle for, well, less efficient alternatives, maybe older tech. This financial barrier can definitely slow down the adoption rate of the really cutting-edge solutions, particularly in cost-sensitive markets where the margins are already pretty tight.
Okay, that makes sense. And moving to another challenge, which feels, I guess, deeply tied to how sophisticated this tech is becoming. We have technical complexity and training requirements. I imagine these aren't exactly simple plug-and-play machines you just switch on.
Oh, definitely not. Modern marking systems rely on pretty sophisticated software, advanced optics, complex automated control systems, and to operate them effectively, to get the most out of them, you really need highly trained personnel. And that specialized resource, that skilled labor, is unfortunately in short supply in quite a few regions. A lack of skilled people can lead to, well, costly downtime or underutilization of this expensive equipment, or even critical errors if things aren't handled correctly. So this complexity often discourages organizations, particularly those maybe in emerging economies, from fully embracing the latest systems, even though the long-term benefits are there.
Right. It sounds like a bit of a catch-22 situation. I mean, you need the advanced tech, but then you also need the advanced people to actually run the advanced tech effectively. Okay, and finally, the third hurdle you mentioned, which highlights sort of varied demands across different industries, strict regulatory standards and customization challenges.
Yes, this can be a major headache for manufacturers, no doubt. Each industry, and often even specific regions or major clients, might demand very different marking specifications. These can range from things like durability requirements, how well the mark holds up in harsh environments, to specific font sizes, or even intricate safety compliance standards, especially for things like medical devices. This means manufacturers often have to constantly reconfigure their machines, their processes to meet all these varying demands. And that kind of customization. It's both time-consuming and pretty expensive. Plus, the stakes are really high. Failing to comply, getting it wrong, that can lead to devastating product recalls or, seized penalties. It adds another significant layer of pressure.
Okay, so quite a few hurdles there. Investment, complexity, regulations. So what does this all mean for the future then? How are these machines evolving to meet these demands and maybe overcome some of these hurdles? The source points to some really interesting trends. Let's start with what feels like a pretty clear trajectory, the widespread adoption of laser-based marking technologies.
Yeah, this is undoubtedly becoming the industry standard, or is already there in many areas. Unlike water methods, the ones that rely on inks or chemicals, laser machines offer clean, fast, and crucially permanent markings without using any consumables. They're especially valuable for marking those incredibly delicate electronics, semiconductors, printed circuit boards where precision is absolutely paramount and any kind of contamination is just unacceptable. So as manufacturers increasingly prioritize higher throughput, faster production, and also greater sustainability in their operations, laser-based systems are really becoming the go-to solution.
That makes perfect sense. Clean, fast, permanent, no mess. And leading right into the next trend, connecting to that bigger picture of interconnected tech, the deeper integration of marking machines with smart manufacturing and IoT platforms.
Right. The latest systems are now being equipped with more advanced sensors, better diagnostics, connectivity tools. It's all built in now. This allows them to communicate directly with enterprise resource planning systems, ERP, and manufacturing execution systems,
Yeah.
MES. This real-time feedback loop, it's genuinely revolutionary for the factory floor. It significantly improves traceability, as we talked about, but it also streamlines quality checks because you can catch errors almost instantly. And crucially, it helps reduce downtime by enabling predictive maintenance. The machine can almost tell you when it needs attention. It's a very clear, very powerful move towards truly intelligent, sort of self-optimizing manufacturing.
Intelligent manufacturing, I
Yeah.
like that. Okay, and bringing in a final globally relevant trend, we're seeing sustainability as a core focus. This isn't just a buzzword anymore, is it? It's really impacting every part of the manufacturing process.
Absolutely. It's huge now. There's significant traction for eco-friendly and low-waste marking solutions, particularly as organizations really strive to align with global green manufacturing initiatives and, consumer expectations too. And laser systems, well, once again, they kind of lead the way here because of their minimal environmental footprint. They entirely eliminate the need for solvents, inks, or chemicals that might need special disposal. But beyond just lasers, companies are also investing more broadly in energy-efficient machinery, machines that reduce the overall carbon output while still maintaining that incredibly high precision we've been discussing. It's about the whole package.
Okay, so we've covered drivers, hurdles, future trends. What does all of this really mean for, you, the person listening, the person who interacts with electronics every single day, probably without a second thought?
Well, I think the core takeaway is that this whole electronic components marking machine market,
Mm.
it's really evolving. It's gone from what was once, a mere supportive process, almost an afterthought, into a truly mission critical component of advanced manufacturing today. It's not just about putting a label on something anymore. It's fundamentally about ensuring compliance, enabling automation, guaranteeing traceability, and driving sustainability across the entire production life cycle. It's this invisible yet completely indispensable layer of information embedded in almost everything electronic.
So maybe next time you pick up a new device, could be your phone, a smart home gadget, or maybe you even get a chance to look closely at a circuit board sometime. Just consider those tiny, precise markings on it, that single line of text, that little barcode. What does that tell you about the complex journey it took to get to you and the invisible, intelligent technology behind its very existence? Fascinating stuff. Thank you for joining us on this deep dive today. Keep exploring the hidden complexities in the world around you.